Now, we'll be moving away from using the uniform distribution, and from now on we're going to be using a normal distribution. Now, there's a couple of criteria first before we can use a normal distribution, and keep in mind you're always going to need to check for these, especially as you guys noticed on the last exam. Information is put together so that you can't just rely on the fact that you know what type of distribution you're going to use because of the section and the text. You're going to have to be able to make those decisions yourselves during the exam. So the criteria we check for a normal distribution are: it is a continuous random variable. Okay, again, that means it's something that's measurable. The graph is symmetric and bell-shaped, such as the one here on the right-hand side. Remember, symmetric means that the left and the right-hand side are the same, and it can be described by the equation at the bottom. We will not be working with the equation in this class, and we will be assuming that if the distribution meets the other criteria above, that it can be described by that equation. So we will not be working with that equation this semester. Now, for normal distribution, any particular normal distribution is determined by the parameters of the mean and the standard deviation for those specific distribution. A specific type of a normal distribution is the standard normal distribution, and that is where mu equals 0. So if our mean is 0 and our standard deviations are equal to 1. So when you're looking at deciding what problem you're going to be solving, first you need to find out if you have got whether you've got continuous random data. Okay, and then you need to be looking at whether or not your graph is roughly bell-shaped when you graph it. And if the left and the right side mirror each other, that tells you of a normal distribution. And then the next question you need to ask yourself is whether or not you have a standard normal distribution. And that criteria is having the mean set at 0 and the standard deviation set at 1. If you're using a standard normal distribution, then you will use the z-score distribution table. If you are using just a normal distribution, which we'll be looking at in the next set of sections on Thursday, you will be working with a different distribution table. So it is very important to make sure that you're clear that you're using the correct table. So here we're working with the standard normal distribution, and we're going to be using the z-score distribution table. Now, once again, remember there is a direct correspondence between the area under the density curve and the probability. So this is the same as we had for the uniform distribution, and the area under the density curve sums to 1, just as it did before. However, the formula here is much more complex due to the bell-shaped curve of the density curve, so we use the z-distribution table, or we'll be looking at later using some computer software. So we're going to have to use a different approach for solving these problems. Now, keep in mind with your z-distribution table, first of all, again, we only use it for a standard normal distribution only. If you have just a normal distribution where your mean is equal to something other than 0 and your standard deviation is equal to something other than 1, then we'll be using a different table. We'll look at that later. You have 2 pages for the z-distribution table, a negative and positive table. All right, and each value in the body of the table is a cumulative area from the left up to the vertical boundary of a specific z-score. This is going to be very important as we look further at looking at our calculations. So remember, the cumulative area to the left up to the vertical boundary of the specific z-score is the what is reported in the table. Okay, so here we have our z-distribution table. We have an area under the density curve. And so in this particular example, the area is equal to 0.1075, and this corresponds with our z-score of negative 1.24. So the z-score is the distance along the horizontal scale of the standard distribution. Okay, so in this case, we'd be looking in the left column in the z-distribution table. That's because it's where we go to locate it. So here our area of 0.1075 corresponds with a z-score of negative 1.24. This means the probability of getting a z-score less than 1.24 is equal to 0.1075. This is going to be very important for moving forward. So if you need to, stop the video here, get this clearly in your notes, and make sure you're understanding this component before we move forward. Okay, so let's practice using the z-distribution table just with a really quick random problem. So here we're going to have a randomly selected adult that undergoes a bone density test, and we want to find the probability that the result is a reading less than 1.27. So this is the problem that we're going to solve. All right, So this is how we use our z distribution table. I suggest you pull up your z distribution table and look at yours while we're doing this one and follow along in the steps to make sure you can get the same answers that I do. Okay, your z distribution tables are in the back of your book. For those of you that are relying on the electronic version, I'm going to suggest that you print out a page of that, because as you are scrolling up and down on that page, you're going to find that it's very easy to lose track of where you are and make a mistake. So think about that carefully. This may be a place where just printing out a hard copy of those tables is going to benefit you in the long run. So using the z distribution table, I'm going to come down to 1.2 under the left-hand column, so we see that in green. So I come down to 1.2 and then I go across that row to 0.07. That is because 1.2 plus 0.07 equals 1.27, which is what I'm looking for. So it's broken down into these two components. So we have 1.2, and then we come over across that row till we find the corresponding column for 0.07 and identify the information in that box. So in this case, our answer is going to be 0.89, 0.80, okay? So that's what we're looking at. That's the corresponding area to the left of the z-score of 1.27. Now, since this problem is asking for less than, we use the area to the left of the reported z-score, and this matches with the construction of the z distribution table, so 0.8980 is our answer for this problem. Keep in mind this will not always be the case. We're going to be looking at a couple of examples where you're going to be looking at asking for having something greater than or looking for a value between two scores. And each of those is going to need to be solved differently. So when we're using our z distribution table, the steps for following it is, keep in mind, first of all, you've always got to check your criteria to find out if you are working with a standard normal distribution or not. So once you know that, you need to draw your graph, you need to mark your known information on it, then you need to shade the area corresponding to the information you wish to know. This is really important to make sure that you're solving the problem correctly, and then you need to think of a way to get the desired information given the conditions that the z distribution table provides only cumulative areas from the left. So these are going to be the steps that we're going to walk through. On the next section, we're going to apply these to 3 different types of problems.